Hi everyone, I'm John and the title of my CSAS lesson is The Integral Parts of Calculus. Now, entering a classroom, very few students have the slightest idea what calculus actually is. Most of them just have this preconceived notion that it's some really hard form of math. So, I not only have the challenge of eliminating this false perception of calculus, but also showing the students some basic skills and actually even defining what calculus actually is. So, my definition of calculus is the math of change, and one form of change that the students have seen is slope. However, slope can only easily be applied to lines, and with calculus, we work pretty much exclusively with curves. However, I'm able to work through the concept of local linearity with the students, so after a few minutes of dedication, they're all able to understand that if you look at a very small portion of a curve, you can treat it exactly like a line. So, for about half the lesson, we work on derivatives, but before that, we approximate them using tangent lines. So, we spend a portion of time on these graphical methods and then move on to the more advanced numerical methods of derivatives. Now, the second half of my lesson is on integrals. But just as we started with approximations with derivatives, we approximate integrals using Riemann sums. So this is very interactive with the students because they get to come to the board and draw rectangles underneath this curve to estimate the area. And after using both one rectangle and two rectangles and three rectangles, someone is usually able to use their intuition to say, the more rectangles we use, the better estimate we have. And then one of them usually expands it to using the concept of infinity rectangles, which is pretty surprising if you're working with someone on a 7th grade math level, but the students we work with are pretty exceptional. So after that, I basically show that derivatives and integrals are kind of like inverse operations of each other, and all of them are able to understand that because they work with arithmetic and adding and subtracting. So that's pretty much that's the extent of the calculus that we use in the class, but that doesn't really show the children how this is actually useful, what they actually need to use this for. So I usually close my lesson on how calculus is important in the world, and there's kids who want to be scientists, but there's also children who want to grow up and develop a business. And it's really surprising for people who don't exactly want to do math how important it could be in whatever field they want to enter. So we brainstorm some ideas and lead a big group discussion, and then eventually the kids walk away with this firm understanding of what calculus is and how useful it could actually be in the real world.